We talk about the levers. Today, or in this video, we will talk about the law of levers. This law, we will use it to solve the problems. What is the law of levers? You can see in this image, the levers consist of fulcrum, O, resistance force, R, effort force, F. And we said that the fulcrum is fixed point, but the resistance force and effort force, we can measure them by Newton because it acts weight of the body. Now I will tell you new things, that the distance between the fulcrum, which is a fixed point, and the resistance force called resistance arm or R arm. The distance between fulcrum and resistance force called resistance arm. That means, Miss Rasha, the distance between the fulcrum and effort force called effort arm? Yes. So the effort arm is distance. That means distance. I will measure the distance with which unit? Yes, I will measure the distance by centimeter or meter. So, the distance between fulcrum and effort force, F arm. The distance between fulcrum and resistance force, R arm. The law of levers said the effort force times its arm equal resistance force times its arm. We talk about the classes of lever, and we said we have three classes of lever that depend on the location of each of fulcrum, effort force, and resistance force. And also we talk about the importance of lever, and we said there are 6 importance of lever. One of them that increasing the effort. That means, Miss Rasha, not all levers will conserve or save the effort or increase my effort. Yes, that's right. In this lesson, we will talk about levers which will save my effort or conserve my effort. That means I will talk about the levers which will increase my effort. Yani by small effort force, I will do my work by using this lever. So I have 3 cases and this point about the levers which will conserve the effort. Firstly, look at this image. This image contains lever in the first class. Miss Rasha, how can you know that from the first class? It's easy. The fulcrum between effort force and resistance force. That means this lever from the first class. So, Miss Rasha said at the classroom, and I will tell you now again, lever which will save or conserve the effort, that lever which has the effort arm longer than resistance arm. This is rule. In the lever which has effort arm longer than the resistance arm, this lever will save or conserve the effort. So, in this image, do you think this kind of lever will save or conserve the effort? Yes, because the distance between fulcrum and effort force, which called effort arm, is longer than the distance between fulcrum and resistance force. Let's see this kind of lever. It's from the first class also, yeah, Miss Rasha, the fulcrum in the middle. Yes, but in this image, effort force or effort arm equal resistance arm. So, it will not save my effort. It will not conserve the effort. Why, yeah, Miss? Because Miss Rasha said the lever which will save my effort should has should have what? Should have effort arm longer than resistance arm. So, and that's not here. So this kind of lever, which is from the first class also, but the F arm equal R arm, will not save the effort. In this case, also in the first class lever, the F arm is smaller than the R arm. So, yes, I can hear you. Yes, that's right. This lever will not conserve the effort. Because Ms. Rasha said that to conserve the effort, there should be that the F arm longer than R arm. And that's not here. Note, the effort force and the resistance force are measured in Newton, as we said before. The force arm and the resistance arm measured by meter or centimeter, as we said. Now, by applying the law of lever on the three types of levers, the three classes of levers, we will find that, firstly, in the first class lever, effort arm equal the resistance arm. That means this lever will not conserve the effort. Why, Ms. Rasha? Because also when the arm of effort equal the arm of resistance, that means the force of effort equal the force of resistance. That means I will not increase my effort. I will not use a small effort to do my work. That means I will not save my effort. Also in the first class lever, but when the effort arm shorter than resistance arm, this lever will not save or conserve the effort. Why, Amis? Because we said the lever which will save or conserve the lever or increase my effort, which will save or conserve the effort or increase my effort, the effort arm should be longer than resistance arm. And that's not here. Now I want to ask you something. Did you observe that when the arm is long, the force is small? What's that mean, Yamis? That means when the effort arm short, that means effort force big. And when the effort arm long, that means the effort force small. I will use a small force, as we said before. Let's talk about the third situation, when the effort arm very long or longer than the resistance arm. In this case, the effort force is small, so this lever will increase my effort. Yani that means this lever will save or conserve my effort. So sometime in the first class, sometime the lever will save my effort. Give reason. Sometime the first class lever save effort because sometime on the first class lever the force arm is longer than the resistance arm, and in this case the effort force will be smaller than the resistance force. Give reason. Crowbar conserve effort. The reason is because its force arm is longer than its resistance arm. So the effort force is smaller than the resistance force. What's the meaning of smaller than the resistance force? That means I will use a small effort to do my work. That means this lever will increase my force or save my force or conserve my force. Let's talk about the second class lever. In the second class lever, resistance in the middle, resistance between effort force and fulcrum. In this case, you can see in this image, the F force is longer than resistance force. So always in this case, always in the second class lever, the lever will save the effort force. In the third class lever, F in the middle, effort force between resistance force and fulcrum, yes, So in this case, always effort force is smaller than resistance force. So always in the third class lever, the levers will not save the effort. So note, the third class lever and some of the first class lever don't save effort, but they benefit us, or we can get another benefit from them. What those benefit? For example, the tweezer. What about the tweezer or the holders? Those lever will increase the distance, maybe, like for example the hockey bat or the manual broom. Increase the speed like the hockey bat. Avoid dangers like the coal holder. Accuracy in performance like the tweezer.